In the second exercise, you're going to use your calculator to work out some probabilities. So the first thing that I would do before I tackle a problem with normal distribution is I would write down what's the mean, variance and standard deviation of the distribution. So remember, we find the mean by looking at this first parameter. So the mean is 30, which is what we've been calling mu. The second parameter, which is 4 squared, is the variance of the distribution. So the variance is 4 squared, and that's what we've been calling sigma squared. Now the standard deviation of the distribution is the square root of the variance, so square root 4 squared, and you'd get 4, and that's what we've been calling sigma. So let's have a look at part A then. We want the probabilities of x being less than 33. So I would draw a little sketch of the normal distribution. We know that the distribution is centered around 30 because that's the mean. And we want the probabilities of x being to the left of 33. So all of these x values here. So we're going to get our calculator to work out what is that area for us. So if you go to our calculator and go on statistics, distribution, normal, CD because we want between two values. Now we need to work out what to put our lower value as, but we want to shade in all the way up to minus infinity, but obviously our calculator can't take minus infinity. So we need to just put in a really, really small number because this curve is going to continue, and let's choose something like minus 9999. I think that'll be small enough because this curve gets closer and closer to the x-axis, and so these probabilities are going to be really, really small down here. That area, it's going to be negligible. So let's put that as our lower, minus 999. As our upper x value, we want to go up to 33, and we want what's the probability of x being between these two values. For sigma, our standard deviation, we put 4, and our mean is 30. So we get 0.773. And this makes sense because we know that we're past 30. To the left of 30, the area is a half, 0.5. So we can just check quickly, we've got a probability greater than a half. Let's have a look at B then. So x being greater than 24. So again, we could draw a sketch of this distribution, and 24 is to the left of the mean, so we're here, and we want to work out what is this area to the right of 24. X is greater than 24, because these are all the x values that are greater than 24. So our calculator can give us those x values again. We're going to put our lower as 24 this time, our lower x value. And as our upper x value, again, this curve is going to continue forever, but it's going to get really, really small, these areas, as we go to the right. So if we put in a large value of x, that would be close enough. So 9999. And we're going to leave the standard deviation as 4 and the mean as 30. And we get 0.933 as our probability. So similarly for C, we want what's the probability of x being between these two values. So let's label 33.5 on our diagram and 38.2, and we want what's the area underneath this curve between those two x values. So we're going to put our lower as 33.5 and our upper as 38.2. And leave the standard deviation as and mean as they were before. So we get 0.171 to 3 sig fig. And then finally, for part D, we can do exactly the same thing, but our region is going to be slightly different. So we want what's the probability of x being less than 27 or x being greater than 32. So let's draw out the distribution. Now, x can be to the left of 27, so less than 27. So we want this area here, because x is allowed to be there. But also, we could have what's the probability that x falls in the region greater than 32. So let's label on 32, and we could have x being there. So we need to include this area as well, because we don't care whether we're in this region to the right of 32 or to the left of 27. So we're going to have to do these two regions separately on our calculators. So we're going to do probability of x being less than 27, and then we're going to plus the probability of x being greater than 32. So to get the probability of x being less than 27, we're going to put our upper as 27 and our lower as a very small number like minus 999, and we get 0.2266 dot dot dot. And we put our lower as a really small number there, minus 999, because we want to go all the way along as far as we can. And similarly here, x being greater than 32, this time we're going to put our lower as 32 and our upper as a really, really big number. So we get 0.3085. And then we just need to add them together, and we get 0.5351. And let's round that to 3 sig fig, so 535. Another perhaps neater way of working out this shaded area would be to use the fact that the total area underneath the curve is 1. So an alternative way to get this shaded area would be to do 1 minus the area in between 27 and 32. So 1 minus this area here. And that's perhaps an easier way of working out the probability, because your calculator can straight away give you between 27 and 32, the area between 27 and 32. So if we put our lower as 27 and our upper as 32, we get that 0.46483. So we need to do 1 minus 0.46483. And that should give you the same area as these two separate shaded regions added together. So let's just check that works. And we get the same answer as before, 0.535 to 3 sig fig.